You can do it offline. You can ask a compiler to give you error message, and you need to practice how to fix error messages, right? For every error message it gives you, you need to learn how to fix them so that the the compiler will not complain anymore. So practice that offline. It's very easy. It's basically about semicolons or and some of the symbols. And here, this one is another type of error we call logic error. So compiler will not tell you what's wrong with it, but I will tell you the answer. The answer is the type of the total, right? It's the whole code is about computing the average of two double numbers. So you are storing them in a total. So that's where your answer is wrong. So try to read code, right? It seems very long, but most of them just C in, C out. If you remove every C in, C out, it's basically total plus x1, total plus x2, total divided by 2, right? These are the errors, we call them logic errors. And it's very hard to be able to detect it by the compilers or by yourself by looking at the code. So it's very important to be careful when you're defining the types, when you're writing some of the symbols. I will also show some examples where you could go wrong. So today's majority of the content will be the if-else statement, or we call the control flows. So until now, every code we have write, they will execute line by line. They will not jump to some other parts. But today we will cover something called if statement. We said this one is very similar to our ternary conditional operator, right? This one is if x is greater than 0, y is assigned as the square root of x, right? And this y equal to square root of x is executed only when x is a positive number. What's the usage of this? For example, if I'm asking you to compute the edge of a square, assuming I give you the area, right? The first thing you need to do is I need to verify, is the area correct? Is this one a negative number? If it's a negative number, it's invalid. We cannot compute the square root. So the first thing we need to do is we check if area is less than 0. If it's a yes, we will do the next line. So as you can see here, we use another symbol we introduce. So we have already introduced 3 types of IO. This one is also an IO. We have one thing called std cin, then std cout, then std cerr. For now, these two are the same. Both of them will print to our terminal or print to our monitor. And this one is for input. The other two is for output. But these two, we will show their difference in the future. But at least for now, you can think for every error message, you can go to the cerr. And we will know in the future, they will be printed to different terminals or different places if we want. We can specify they print to different places. But at least for now, these two are the same. Cout and cerr are the same, at least for now. All right. So this is the example we typically use. If area less than 0, we just put some error message says it's negative. And here is the relational operators we have learned about, less than, greater than. We will use it today. First thing is don't confuse with equal or assign, right? Let's use an example. If our input is, for example, int x equal to 10, y equal to 20, and what we do is if x equal to y, what we will do is cout x empty space and y are equal. Yeah, let's just do that. All right. So we are first defining 2 variables, x and y. x is 10, y is 20. And we say, if x equal to y, we will see out x and y are equal. All right, so if I run it, what's the output? Nothing. Yeah, nothing will be output, as you can see. If I run it, nothing happens, right? What if I change it to a sign? What will happen? If I change equal to a sign, it's a warning, it's not an error. It's a warning, you can still execute it. What will be output? What and what are equal or nothing output? First, we will check if this guy is true or false, right? First, we will execute this line, x assigned to y. So both x and y will be 20. And then it will becomes if 20. 20 means true. 20 means true. So we will execute line 15, right? So let's run it. 20 and 20 are equal, right? Because of the assignment, you have changed the value of x. You are not comparing x and y. You are doing assignment, right? You're assigning x to y to x. Then you are doing if x, then see out x and y are equal, right? So these are some of the mistake beginners typically have. They forgot a equal, but it's still working, right? And as you can see, there's a warning in my IDE, right? But it's not always the case. For instance, if I copy my code to my Linux machine, let me connect it to my Linux machine. Wait a minute, let me remove it, create another one. All right, this is exactly the same code I just copied to my Linux machine. If I compile it, nothing happens, right? No warnings. And I can still run it. 20 and 20 are equal. There's no warning. How can we enable the warning? There's one option in G++ called -W. This is a warning. And you can enable all the warnings. -W all. You are enabling all the warnings, and it will give you some of the warnings, right? But it's slightly different. It says suggesting parentheses around assignment used as a true value, right? You are using the assignment as a true value. So it is suggesting using parentheses so that people kind of know you are doing assignment and then you are intentionally use this assignment as a true value. But instead in here, it says it's a warning using the result of an assignment as a condition. So this one is more meaningful than the compiler I did in my Linux machine. So different compilers will have different warnings. Some of them don't have any warnings, but this one has a good warnings, right? So that's the mistake people will have, right? We talk about compiler errors will be easily get by compilers. You can fix that. Logic errors, you cannot do that because you have to look by eyes. And some of these obvious errors people will have, compilers will give you the warnings. Right. How about it's a 0? What will be the output? X equal to 10, y equal to 0. If x equal or x assigned to y, what's the output? No output. Yeah. If this is the case, there will be no output. There will be no output. Because after x assign y, both x and y will be 0. So it will becomes if 0, do this, right? If 0 means if false, we will directly jump out. So there will be no output. But we can still see the outside, right? This is typically the case you would write. If they are equal, we print something. If they are not equal, we print are not equal, right? So we can run it. It'll say 0 and 0 are not equal, right? It seems weird. X assigned to Y, 0 and 0 are not equal. It's because you are not doing comparison, right? You are doing assignment. So that's the typical error people might have. So if we consider the control flow of this program, right? So we typically draw it in this way. This is the flow of a program. Then we have a condition. We typically represent our condition in this way. We say X assign Y, right? If it's true, we are executing line 15, right? Line 15. If it's a false, nothing happens. And when both of them finishes, we will execute line 17. Line 17, right? This is the typical control flow we would draw. So first we have a condition here. Then if the true, go to left. If false, go to right. And as you can see, if it's false, we do nothing, right? This condition. And after both of them finishes, we go to line 17. So if it's true, as you can see, it will execute both line 15 and line 17. So there will be two outputs. If it's a false, first it's nothing, then line 17. We will output one of them, just outputs the line 17, right? So this is how we draw a branch. We call it a branch if a condition. And we are asking, is this condition equal to true or not, right? We're asking this question. And the result of your assignment is basically result of X. If X is 10, Y equal to 0, after Y is assigned to X, both X and Y will be 0. So X will be 0, right? The output will be false. We will go to here, then here, then here, then line 17. Now both X and Y are 0, so we will see out 0 and 0 are not equal, right? So that's the idea about this one. We should be careful when we write down equal or assign. And the reason we can do this is because any number or anything that's almost anything can be converted into Boolean type, can be casted into Boolean type, right? For integers, 0 is false. All the others are true. For characters are basically integers, right? This \0 is the ASCII code 0. ASCII code 0 is a false, and all the others are true. We will learn this one when we go to the strings. And for the pointers, we will learn later. If it's a non-pointer, it's a false, others can be true. So almost anything can be converted into a true or false. So if we put assign here, it's almost valid, right? Compiler will not complain anything. You will still get the answer, but the answer might be wrong. This one, we also talked about it, right? This one is due to the round-off errors. Well, X is assigned to square root of 2, but because we assign it to double R, so we know it has limited precision. When we multiply it again, we will not get the exact 2, right? It will be slightly up or slightly lower than 2. And we will jump to the else part. So we haven't talked about the else. So let me write it down. We will have the first condition is, does R times R equal to 2, right? If it's true, we do something. If it's false, we do something. If it's true, we will execute this line. Let's call it 1, 2, 3, 4, 5, right? We will execute line 3. If it's false, we will execute line 5. This is the else part, right? Else means the false part. So this is the condition we are checking. And we know we said R, because of the round-off errors, r times r doesn't equal to 2. So we will go to this part, right? We will go to line 5. We will execute this line. We will output square root of 2 squared is not 2, but the real result, right? The real result. So this is a line. Let's run it in our Xcode. Let me copy that. std. All right. Right, we get the line 17 is executed. It says square root of 2, this is a number, right? If this one is squared, the answer is not 2, but 2. Right, it seems weird, right? What's the problem? What's the problem? See the tricky thing here? Square root of 2 squared is not 2, but this one, right? Square root of 2 is not 2, but 2. It says r times r is 2, right? What's the problem? The problem is precision, right? If we set precision 20, let's see what's the output. Now you can see the difference. Square root of 2 is squared is not 2, but 2 point, a bunch of O's and a 4441, right? So it is because the output, you cannot see the exact number. All right, so anyway, we have proved that this one will go to line 17. And the main thing I want to talk about here is never compare doubles in this way, right? It will have round off errors. So what can we do? What can we do is this one. As long as two numbers are close enough, we are fine. You don't have to be exactly x equal to y. If it's a floating point number, you say x equal to y, there will be some errors. What we want is these two numbers close enough, right? Their absolute value of difference should be less than very small number, epsilon. For instance, in this way, right? As long as r times r minus 2, the absolute value is less than 10 to the power of negative 10, right? It's a very small number. As long as these two numbers, r times r and 2, are close enough, we could say this one is 2, right? So when you compare two floating point numbers, most likely do not compare with equal. Compare using the difference, right? As long as it's close enough, it will be fine because of the round off errors. Any questions? What is ABS in Chinese? What is, yeah, 绝对值, absolute value. All right. So next thing I want to talk about is called a block. So a block is something you enclosed by a brace, right? If you combine them with a brace, it's called a one block. And everything in the block is executing line by line. So if you look at here, if its area is less than 0, we output some error message, then we return 1. So if you enter this block closed by this brace, after executing line 3, you will execute line 4, right? So it's one block. It's one block. And we might have multiple blocks, right? Everything between the main function is a block. So a good compiler will help us to identify the block, right? When I am, as you can say, when I am clicking on, let me put here, right? When I am clicking on this brace, it will automatically highlight this brace. It will tells me which block I am referring to, right? If I put a brace in here, right, it will automatically tells me this one means this block, right? It will help me with that. If I put the wrong one, right, as you can see, if this one matches with this brace, and this one is not matched. So there will be some errors. It's expecting another brace. So you can put another brace here. So everything will be matched, right? Every brace will match it with its block. So this is you are combining the one brace with another, and you are saying, okay, main function is a large block because of the brace, right? This is a block. This is the one block. It's a large block, right? This one, another block. This is a block. This one, another block, right? It's a block. And the brace will always matching with the nearest brace, right? If you put a brace, like I did in here, right? Now this brace will be combined with this guy because it's the nearest one. So that's the basic stuff about the brace, as simple as just a brace. So a good habit is indentation, right? You are making sure the whole block will have the same indentation, right? The block inside of the main function have the, for example, 4 empty space. Now for the if else block, it has 8 indentation. So this is the way you can do. Try to making sure your code is readable, right? Making sure every block is beautifully aligned. So as an exercise, for example, for a square, given the area, output the side length, right? For a square, if I input the area, please output the side length. And if the input is negative, print some error message. Let's do that. First one, we can define the area, right? And this is the area someone need to see in. I will skip the hint message. Let's just do that. Someone will give you the area. And then you can compute the length, right? We can say double length equal to square root of area. And let me output this length for the new line, right? Let's run it. If my input is 4, the output is 2, right? It's correct. The questioning comes from if my input is -1, right? The output will be, this one is read not a number, not a number, NaN, not a number. It is because of the output of the square root of area of a negative number. So what you need to do is you need to check, is area negative or not? If area is a negative number, what you should do is first output some message. You could see out, you could see error. It will be basically the same. Negative area input, right? And what you can do is return. So if area is a -1, so area is less than 0, it's a true, I will execute line 16 and 17. Right? First, I will output a negative area, this message, then I will return. We said whenever we see a return, the program stops, right? Let's run it. For the -1, we say negative area, right? Negative area. Then we return 1. Return 1 means ending the whole program. And the main function, we will jump out of the main function. And the program ends with a code 1, right? We typically use 0 as a message saying that the program exit successfully. If it's a 1, we typically say there's some errors happening in the middle. It's just a convention, all right? But you don't have to follow that. You can say return 0, it's fine. It will be totally fine, right? What you can do is return 0, it's also fine. There will be no difference in your output message. All right, so let's see, what if I don't have the return, right? What if I don't have the return? What will be my output if I inputted -1? What will be my output? What if I output -1? it will first execute line 16, right? Because there's a no return, I will continue run line 19, then I continue run line 20. So it will first assess negative area, then output the length, which is not a number, right? So this one is better to have a return so that it will not execute more code. So this is about the branch, right? Your flow or your program will execute which line based on the condition of your area, the condition of area less than 0 or not. If this one is true, we will run line 16 and 17. Otherwise, it will not run this. It will directly jump out to the remaining part. So that's the control. And as you can see, the code is like this, right? Basically the same as what I have shown. So another thing is you could also validate if the input is correct or not. So as you can see here, let me try it. Ask me to input a double, right? How about I give it a 5, right? FIVE instead of number 5. When you run it, there will be no error message. It says everything works successfully. Everything is so beautiful, right? But the only thing is the answer is wrong, right? We are expecting square root of 5, but indeed it's not. So in here, we need to check if cin is successful or not. And what we can do is std cin dot fail, right? We could check does cin fail or not. We could have another branch says if cin fails, we also want to return. We want to jump out of the current application. We says cin fail, right? Let's do it. We could type 5, right? It will say cin fail because it doesn't get a double. It gets a bunch of strings, right? Cin will fail, and we can skip because the area is not correct, so we don't have to execute anymore. So that's the basic idea about invalidate or checking if the input is correct or not. So this is the way. And what if both of them, I just want to say error, right? And as you can see, these two blocks are basically the same. Can I combine these two branches? Can I combine them? Remember, we have the logic operators, right? Or, yeah, we could say either this one fail, or if you success, if area is less than 0, I could do this, right? So if you run it, test the 5, it says error. If you test a -1, it says error, right? So this is the way. What's the difference between this and this? Let me see. Area less than 0 or cin fail. Is line 15 exactly the same as line 16? Are these two lines exactly the same? It should be the same, right? But indeed, it's not. Remember lazy evaluation, right? Lazy evaluation, if it's line 15, if cin fails, we will not check area. In the second case, we will first check area, then check C, right? If area is less than 0, yeah. So basically, this is the way, right? Our logic should be first one, we need to check cin fail or not, right? Is cin correctly? If we correctly getting the area, then we check is area less than 0 or not. So the execution order is different. We will see that when we talk about the lazy evaluation. So line 15 is the suggested way, preferred way All right, we first check the seeing, then check the input of your seeing. All right, this one. Which one? It's or. It's or. Yeah. Yeah. So this one means if seeing fail is true, I will skip compare area with 0, right? If it's true, I will skip that. It's a lazy evaluation. If it's false, it means our seeing success. Seeing success, we can check if area is less than 0 or not. So this one makes more sense than the next line. Good. So when we're comparing, right, in the conditions, we can write comparing some of the strings. So here are some rules about comparing strings. So first one, if it's we are comparing character by character. For example, when we compare cargo with cat hold, it will compare first C with C, the same, A with A, the same, then R with T. So we will ask the ASCII code, right? ASCII code. In ASCII code, R comes before T or T comes before R. So we need to ask this question. We know that this one is actually following the alphabet order, right? A, B, C, D. So because R comes before T, we know R's ASCII code will be smaller than T's ASCII code. And when you compare two strings, the first thing that different, we will decide their order. So in this one, cargo is less than cat hold because the R is less than T, right? CA and CA are exactly the same. R is less than T, so cargo is less than cat hold. And if it's stop early, right? Car and cargo, the first three characters are exactly the same, but car is shorter. And so this one is less than cargo. And when we go to the string class, we know there's actually one extra character after car. It's called \0, which is ASCII code 0. But we don't need to remember that. We just think about this one as, because this one is shorter, so this one is less. We do some exercise. First one, Tom and Jerry. Who is this a less or greater? Tom and Jerry. Which one comes first? Jerry. Jerry comes first, right? So T is greater than J. So Tom is greater than Jerry, right? Tom and a tomato. You can give me less than or greater than. Less than, greater than, greater than. Are you sure about greater than? Oh, you're right. Yeah, less than. All right. How about next one? Yeah, you are comparing lowercase c with capital C. Which one is larger? Yeah, lowercase c is larger, right? So lowercase c is larger. This one, we never talk about a blank space and a B, right? We compare a blank space and a B. Yeah, B is larger. Uppercase H, lowercase h, right? Yeah, smaller. It's a plus and a A. Indeed, I cannot remember. Let's do that. So in the remaining part, for the remaining, so you can do that offline. But for this one, I want to show you in a program, right? How to do it. C++ and a car. Let's define a bunch of variables. First one is variable A, call it C++, give it a B, call it a car, right? We could have a branch saying that if A is less than B, what we do is we create a block, right? Create a block for the true part. We could see out A is less than B. Right? We could do that. And we could have also have an wait, let's just do this one. Right? If it's less than, yeah, the answer is C++ is less than car, right? If we make it a lowercase, it will not be the case. Now A is greater than B, so nothing happens, right? So it really depends on that. You can check every answer in this way for all the exercise and match it with your understanding. So I will skip the remainings. So in this one, a compilation error, it will GCC compile, will it generate some errors? 0 less than equal to x less than equal to 100. Will this one be an error? Yeah, it's valid. It's correct. It just doesn't. It just doesn't what. It just does something that's not you are expecting, right? What it does first, comparing 0 with x, it will give you either true or false. Then convert them into a number, 0 or 1. Then this 0 or 1 or true or false will compare with 100, right? So the answer would be always true, right? Either 0 or 1, they will be less than 100. So no matter what your x is, the answer is true. So it's not a compilation error. When you write it, compiler will not complain. But indeed, what you are expecting is something like this, right? 0 less than equal to x and x less than equal to 100. This is something you should write. But the first one, if you write it this way, compiler will not complain, right? But this one is the correct, logically, semantically correct. And I'm asking you to remember the table, right? When both A and B are true, A and B are true, right? You have to remember this table so that you can write your program correctly. And you can do this exercise offline, right? If P is false, Q is false, R is false, what's the answer of P and Q or negate of R, right? What you can do is I will show you one example. Yeah. If P is false, Q is false, P and Q is false. If R is false, negate of R is true, right? False or true, answer is true, right? You can do this exercise and using this table to remember what does it mean in these logic operators. So next we will talk about what do we mean by lazy evaluation, all right? So this is the control flow. This is a typical control flow. And here is an example. It says if country equal to USA and weight less than 1, we do some line. So because there are two conditions, right? We are actually checking one by one. First, we will check, is country equal to USA or not? If it's true, we will continue to check if weight is less than 1 or not. If it's false, we will directly jump out of the whole block and executing anything after. So for this one, it will be only checked when country equal to USA. So remember last time, instead of writing this one, we write plus weight, right? Something like this. If this is the case, this is the plus weight. This one will be executed only when country equal to USA, or only when this one is true, right? If this one is a false, it will jump out. Jump out, we mean if this guy is false, because compiler knows the answer, right? False and anything is a false. So they will skip the remaining part and they will do something like this. It's also similar to our if cin fail, right? Or area less than something. This one is similar to this one. This one is similar to this one, which is this one. How do we read it? If state equal to high, hi, or state equal to ak, we do something. So it's basically first check, does this one equal to HI? If it's true, right, we will skip the second one. So similar here, if C in fail is true, we will skip comparing the area. So that's the control flow. So if you can remember this picture, this graph, you will be able to understand what do we mean by lazy evaluation, right? Lazy evaluation, as long as the answer is known, we will skip the remaining checking or all the remaining operations. And we will evaluate from left to right. So here is some examples. You can play with it, but it's actually very simple, right? X is 100, and 100 means true. Y greater than 0 is true. True and true is true. Second one, a little bit complex, right? Because we have plus. Because of the A equal to 0, plus A is 1. 1 is true. Whenever there's a true, we know the answer is true. We will skip the remaining, right? You can test that. And the last one, similarly, but this one, I returns 0, it's a false. Anyway, go back and do this exercise and draw the pictures like this. Draw the pictures like this and try to understand what's happening in these examples of lazy evaluation. So for lazy evaluation, I'm not asking you, I'm not suggesting you to write code in this way. This example 2 and example 3 are bad examples to write code. I'm writing here to help you understand the control flow. If you guys can draw the control flow like this, you will be able to understand why the answer is, when you output it, you will be able to understand why the output is like that. All right, so until now, we only talk about the if part, right? If the area greater than 0, we do something. We also can include the else part, which is the false part. And this one, right? If area is greater than 0, greater than or equal to 0, we do the work. Otherwise, we do the line 4. So this one, sometimes we would suggest the people to write down your comments. So for example, in this one, right? Sometimes I would write down my comments like this: A less than B. It's easy to see, but let me write down the else part. Else std cout is, for example, greater than, right? I want to see, am I writing correctly? So sometimes I would put my comments here. I would try to negate the condition here, because the true part is A less than B, right? So I know else part means A is greater than or equal to B, right? If the A less than B is false, it means A is greater than or equal to B. Sometimes I would suggest writing comments in this way. It's for your own understandings. So if you have these comments, you know this writing is incorrect, right? It should be greater than or equal to. So something like this. So when you run it, it has C++ is less than car. And if you change it a little bit to lowercase c, you will output C++ is greater than or equal to car, right? So that's the else part. It's very similar to if, but just the condition is false. You execute this line. All right, so it's very similar to write it in 2 lines, right? First line checking greater than 0, second line checking less than 0. But this one is not suggested, right? This one, the lower part is not suggested because you are asking your program to test it twice. But indeed, you only need to test it once, right? For the first one, you only test it once. If the output is true, you will do this. If output is false, you do this. But for the bottom part, it is two testing, so it's slower. The previous one is faster. But basically, semantically, they are exactly the same. And this is how you can draw the flowchart. All right. If it's less than 0, it's false, jump out. If it's true, print some message. So you can play with it. So we have another thing called a nested branch. Instead of having just one line of code inside your block, right? We call it block, the block for your else part. What we can do is we can make it longer, right? We can have another if else in it. So for instance, if I can say if A is not less, greater than B, right? We could see out this else greater than B, or we could see out this one is equal to B, right? So initially we have only one line in the else part. This is the block. This is the block for else, right? The whole block is for the else part. And instead of just one line, we have a if else statement, right? We are, as I said, we would suggest you writing some comments in here, right? What is the condition here? Is A equal to B, right? Because when you jump into the else part, you know A is greater than or equal to B. And if you have the first condition says A is greater than B, the else says A does not greater than B. So because A is greater than or equal to B, so the only remaining condition is A equal to B, right? So if you write down this kind of comments, it will be easy for you to verify, are you writing the correct code? So yeah, this is called a nested branch, and everything could be nested. By the way, this one, let me go over this one. So someone asked you, what's this? All right, this one is a program we will implement later when we go to the for loop, finish this, the whole one, maybe next week, right? This is a function we will write later, but not now. And assuming this one is the whole program is about testing whether a number is a prime or not. So what is a prime number? Prime number. Prime number. 2, 3, 5, 7, 11, 13, 17, 19, right? Yeah. Prime number. So as you can see in prime number, there's only one even number, right? Even number. And all the others are odd number. So in this simple implementation, I just combine them or not, split them into two parts. This part and this part, right? This if, this else. What is this part? What is number mod 2? Is this an even number or odd number? Number mod 2. If number mod 2, what does it mean? Yeah. So number mod 2, right? I put it in the branch, in the condition part. I'm asking, is this one a true or false, right? True means 1. Is n mod 2 equal to 1? If it's a true, it's a even number or odd number. Yeah, it's odd number, right? Odd number. This part is an even number. And if it's even number, right, we could also split it into two parts, right? For even number, if the number is 2, we know it's a prime. If it's not 2, number not equal to 2, but number is even, right? If it's even number but not equal to 2, we know it's not a prime number. So for the false part, it's easy, right? For the if part, we could have a function call. This is a function call we will implement in the future. And we could say test it. If it's true, then it's true. If it's a false, it's a false. Anyway, so this one is called nested branches. All right, that's the only thing I want to say in here. So you can skip about what's the test prime. You can skip about that. So let me go to this part. And the thing is, we sometimes use a block. Sometimes we will skip the braces. when there's only one line, right? If there's only one line inside the block of the if statement, if this part, if there's only one line, we can skip the brace. As you can see here, right? We don't have the brace here. If there's only one line, it's fine. If it's more than one line, you need the brace to create a block for it. And the whole thing, the whole if else part is also just one statement. The whole thing is a one statement. So you can continue skip this part here, right? You can continue skip it, right? And we say blank space means nothing in C++. You can skip blank space, right? You can skip blank space. You can do something like this. How can we read it? If A less than B, we can see out A less than B. Else if, it's called else if. Else if A greater than B, we do A is greater than B, right? Else, which is the remaining part, which means this one is false, this one is false. We go to the else part. We will output A is equal to B, right? We can write it in this way. And this one is totally valid, and we could continue, right? If A equals to, this one is not good. Let me change it int A equal to 10, B equal to 5, right? If A equal to B times 2, right? A is double of B, and we can continue writing else, see out. We can write the conditions on and on and on. We can have as many else if as we want, right? We can do it with many layers, and without the braces, right? We said we want to skip the braces. Without the braces, there's something called a dangling else, especially when you only have the if part, but we skip the else part for some of the branches, like this one. So what's the purpose of this? The purpose of this is you're asking the user to see in some number, right? Your purpose is if number is between 0 to 9, you would add 1 digit. If the number is in 10 and 99, you want to increment 2 digit, right? So this is your purpose. But your question is, if you write your program in this way, it's not doing what you are expecting. So it is because you forgot the braces. Let me tell you the thing. First one is blank space means nothing, right? It's different from Python. If you write Python, this else will be matched with this if. But if you write in C++, else will be matched with the nearest if. These two will be matched together. So how about let's go through some examples. What if number is 8, right? If number is 8, because this if is combined with this else is combined with this if. Let me erase this line. This else is matched with the nearest if. It is the same as putting a brace here. So everything in the middle is the then part. So if number is 8, we're asking is number greater than 9? The answer is false. Nothing happens, right? How about we get 150? If it's 150, we comes in. If number greater than 9, it's true. We get in. Then asking if number is less than 100, the answer is a false. We go to the else part. We plus 1 digit, right? If it's 150, we will execute plus 1 digit. So this is wrong, right? This is not what you are expecting. And the reason is because of the dangling problem. So what you should do is actually, instead of doing this, you're doing this, right? If you format your code using the VS Code or any lint, they will automatically align the else with the matched ones. So if you do the formatting, they will tell you these two match together. And if you want to resolve the problem, you need to combine them with a brace. So the whole thing becomes a block. This else will not match with the block inside the if part. It will match with the previous if. So this else will match with this one because of the block. This is the whole block. It will not point to the something in the middle. Any questions? Yeah, good. All right, so we have another writing of if else, right? We said we could say if else if else if else if else if. We could have as many else if as you like, right? So we have another grammar called switch. So this is the switch statement. You can read it like this. Switch means jump to some line based on the value of digit. If digit equals to 2, it will jump to here. This is the combined with a switch case, right? Switch case, switch case, switch case. So if digit equal to 2, it will jump to here. Digit equal to 9, it will jump to here, right? So that will be the, so how can you rewrite it in if else statement? It's easy, right? If, let me write it in Xcode. All right, instead of assigning to it, let's just output it. So wait a minute. We could have some integer called a digit, right? We ask the user to give us digit, and we could say std. We could say if digit equals to 0, right? We could see out 0, else if, let me copy that. Else if digit equal to 1, see out 1. Else if digit equal to 2, see out 2. Let me skip that. Std see out others. All right. So you could write your code in this way: if, else, if, else, if, else, if, and if you do a input, for example, 1, right? It will automatically print a 1. Nice and clean. Or what you can do is, let me hide it. Comment this out. We could also write a switch statement. We could say digit, right? Switch digit. If the digit is a 0, we do std see out 0. And if it's 1, we could see out 1. If it's 2, we could see out 2, right? Default is the last else part. Default means doesn't match any of the previous numbers. We do default. We do default, see out others, right? We could also run it. For example, if we output 1, it will print 1. These are exactly the same. Switch case and if else are exactly the same. The only difference is people tend to sometimes prefer this way because it's nice, right? You are comparing the value of digit with the values of 0, 1, and 2. All right. So whenever there's a match, it automatically jumps to the line, but it didn't ask you to stop where to stop, right? Stop is controlled by the break. Assuming we don't have the break. Assuming we don't have the break. Let's see what will happen. If my input is 1, it will print 1, 2 others. right? We said switch only tells you where to start. When the input is 1, digit equal to 1, it will jump to line 19. It will execute this line 20, cout 1. It will continue, cout 2, continue, cout others, then stop. But whenever there's a break, for instance, I break here, right? If I break, this is the only break. If I print it, if I type in 1, it will print 1 and 2, right? It will, when it's 1, I will jump to line 20. I will output 1, continue, output 2. Whenever I see a break, I will jump out of the switch statement. So that's the case. So beginners typically forget the break. The break is very important unless you intentionally do that, right? What do I mean by intentionally do that? Let's give you an example of how to use it. 0, 2, 4, cout even. 1, 3, 5, cout odd, right? You could do that. If it's 2, it says even, right? When it's 1, it says odd. Again, it only controls where to start, right? When the input is 1, digit is 1, it will automatically jump to line 21. It will continue run until see a break. So there's only one output, which is cout odd. So that's the usage of switch. So typically, people do the switch for the usage. For instance, let me give you an example. Let me show the final example first. Right. So there's a pros and a cons. Pros are all the branches are, you will see they have the same values and they are easy to see. But there's also some bad parts. They can only be applied to some tests. That's constant integers. As you can see, the 1, 2, 3, or the character 1. Character 1, if you look at the ASCII table, it also has some numbers. They are constant numbers. So you could only compare numbers. You cannot compare something other than numbers. All right, this has to be a constant number. You cannot say if digit equals to 0 plus x, assuming let me say int x equal to 10. You cannot do that. It will complain. It's not comparing digit with 0 plus x. It's only comparing a number with a constant number, right? It has to be a constant. It has to be a 0. You cannot make it a long sequence of expression. In that case, you need to go back to use if else, if else, else, if else, if else, if until the last else, right? They are exactly the same. And how typically people use it? People sometimes use it like this way. Okay, cout, for example. Typically, you would see please, let's say like that. Remove your old file, right? Yes or no, right? People typically do that. And seeing some of the character, we call it a choice, right? Seeing a choice, right? And then we can case choice. If it's a yes, if it's a no, right? We could do something case yes, no digit. Semicolon. We could blah, 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 do some work, right? Do some work here. So that's typical usage of switch case, right? You can ask a user, are you sure you want to remove your file? Then you can type in your choice, yes or no. Then you can compare your characters, right? If it's a yes, you do some work. If it's a no, you do some work. So that's the basic usage of switch case. It's exactly the same as the if else, right? This is the if else. So yeah, that's basically what we'll cover. And here is an exercise. How can we compute the text, right? If your income is in this range, can this one be done in switch case statement? We talk about two types, all right? First one, if else statement. Another one is a switch statement. Can this one be done in switch? You cannot, right? If your income is in this range, you cannot say, does this income equal to some number, right? That would be too many. The only thing you can do is you can do a range, right? If it's in some range, if the income, right? Income is less than equal to 30,000, right? You do some compute the total tax. You could give a double tax equal to 0, right? Let's just assume starting from income 0, you will be taxed, right? And everything in the middle, if it's less than this one, indeed, let's do it in another way. So any number in this range, right? They will be taxed with 3%. Let's write it naively. How can it be naively? Let's erase double income and ask the user to see in income, right? And if the income is less than 30,000, your tax would be plus equal. It means equals tax plus, right? Your income times 3%. 3%. It's a magic number, but I just quickly write it here. All right. So this is the if part, right? Then else part, we can make it really complex. Else part, first, we need to add in 3,000 times. That's the text for the range between 0 to 36,000. So in here, income is greater than 36,000, right? And we will continue with the remaining part, indeed. Right? And for the remaining part, if the remaining part, they write it in this way. But anyway, let's just assume in this way. Right. All right. Make it another way. Else if income is less than equal to, what's the range? 144,000. Right? How can we do the text? Equals, let me write it this way, text equals to 36,000 times 0.03 plus income minus 36,000 times, what's the percentage? 10%, 0.1, right? You can do else if income less than equal to next range. What's the next range? 300,000. You can compute the text, right? A bunch of if-else statement, but this is not the easiest way to write because there will be a bunch of repeated typing. But anyway, this is something you can do, right? You can write it on and on and on. All right, any questions on this? We said this one cannot convert it into a switch because it's a comparison, not equal. Switch can only be used for equal, right? Digital equal to 1, digit equal to 2. That's equal. If it's a comparison, you cannot do that. For a comparison, you cannot do that. You can only use the if-else statement. Practice this, and you will be able to understand the basic